Maths is easy.
A. Given that 2% is longer than 82, the mean is 75, and we're missing the standard deviation. So to do A, we must find the inverse norm. The error is 0.02, and we will use right tail. So the z-score will be 2.0537, will equal with the x, which is 82, minus the mean, which is 75, divided by the standard deviation. So the standard deviation will nearly 3.41. Okay, B, find the probability that's more than 80. So we will use CDF more than 80. So the lower bound will be 80. The mean is 75. The standard deviation is 3.41. We have the probability nearly 0.0712, correct to 3 significant figure. Okay, C, find the probability that less than 82 given that it's longer than 80. So it will be A given B. So less than 82 given longer than 80. So it will be the probability between 80 and 82 divided by the probability that's longer than 80. So we will have, so this will be the lower bound 80 and the upper bound will be 82. The mean is still 75. The standard deviation is still 3.41. So it should be 0.05119 divided by 0.0712. So it's nearly 0.719. Okay, D, expected number of flights that more than 80. That's 64 flights in total. So to find the expected value and multiply with P, which is 64 multiplied with 0.0712. So it's nearly 4.56 flights. Okay, E, find the probability that more than 6. Number of trial is 64. The successful rate is 0.0712, and we need more than 6. That means it will be 1 minus the binomial CDF of 6. So put everything into the calculator, we will have nearly 0.169. Question 9. A, find C. We know that the total probability will be 1. So to find C, we take 1 minus these numbers. So C is 0.1179. Determine whether the lottery is fair or not. So we will find the expected value of this data. So the expected value will be 0.0.85 plus 2 times C, which is 2 times 0.1179 plus 10 times 0.03 plus 50 times 0.002 and plus the grand prize is 1,000. So plus 1,000 multiplied with 0.0001. And this one will equal with 0.3758. So it's not fair because you have to pay $2 for each ticket. If the expected value is 2, it's a fair game, but in this case, it's not. Okay, C. Given that the grand price is not 1 and it's continue to double, okay, find the general term of the price. So we know that this will be a geometric sequence with U1 is 1,000 and the ratio is 2 because it double every week. So UN will be initial U1 multiplied with the common ratio power n minus 1. So this will be the answer for C. Okay, D, find P, which is the expected profit. So if you want to gain profit, the expected value in here must bigger than 2. So first we will find the expected value for this group first. So it will be 0 multiplied with 0.85 plus 2 multiplied with 0.1179 plus 10 multiplied with 0.03 and plus 50 multiplied with 0.002. And that's one we will have, it will be 0.6358. Okay, so the expected value of total will be UN, which represent the grand prize, multiplied with 0.0001 plus 0.6358 must bigger than 2 in order to gain profit. So simplify, we have UN multiplied with 0.0. So we will sub UN with the answer in C. So UN will be 1,000 multiplied with 2 power n minus 1 multiplied with 0.001 will must be bigger than 1.3642. So 2 power n minus 1 must bigger than 13.642. So n is 5. Because when n is 4, this will be 4 minus 1 is 3. So 2 cubed, only 8, still smaller. So n must be 5. So when n is 5, un will be 1000 multiplied with 2 power 4, which is 16,000. So bigger. So this is correct. So the grand prize now is 16,000. Okay, now to find p. It will be, we stop in here and then minus 2. So 16,000 multiplied with 0.0001 and plus 0.6358 minus 2. And the expected profit will be $0.2358 per ticket buy. And we are done.